Subsets of real numbers. When we talk about numbers, there's 5 different categories that we can put them in. Let's start with the first category. We'll call them natural numbers. And if you want, for short, we just use this letter N with 2 lines on it. The natural numbers are the numbers you learned as a small child when you first learned to start counting. They're just the counting numbers starting at 1, 1, 2, 3, and so on. Now the whole numbers are very similar. You just, for short, write a W. And the whole numbers are all those counting numbers, but this time we can start at 0. 0, 1, 2, 3, and so on. Those are called whole numbers. Now the integers are similar, but we can start including negative numbers. So we can go -2, -1, 0, 1, 2, and so on. And surprisingly enough, we don't use the letter I to describe integers. We use the letter Z. And that's just because the letter I in math has a lot of other different meanings. So we use Z, or Z, as we say in the British system. And then we have the rational numbers. And again, R is used a lot in math, so we use the letter Q to describe rational numbers. Now, there's a lot more rational numbers. And what a rational number is, it comes from the word ratio. So it's a number that can be written as a fraction. So any number that's written as a fraction with integers on the top and bottom, could be negative, could be positive, or any decimal that stops, or any decimal that repeats, these are all rational numbers. So let me just give some examples here. So some examples of rational numbers would be numbers like 2/3, that's a fraction, or -1.25, that's a decimal that stops, or 3.4 repeating, 3.44444, you can put a line on top. These are all rational numbers. Okay, and lastly, we will talk about irrational numbers. Now again, the letter I in math is used for different things. So to describe irrational numbers, the set of irrational numbers, we use the letter H. And basically, these are going to be the opposite of rational numbers. They are what I like to call ugly decimals. They're decimals that will never stop or never repeat. Some common examples of these are numbers like anything that has a pi in it. We use pi a lot in math. But if you actually took out wrote it as a decimal, you'd get 3.14159. And you'll quickly see that this decimal goes on and on forever, and it doesn't stop and it doesn't repeat. It's what I call ugly, so that's an irrational number. Or often we have square roots that don't simplify to something nice. Like let's try the square root of 2. If you typed that in your calculator and you saw what it was as a decimal taken out, you'd get 1.41421. And basically you'll quickly see that it, as a decimal, doesn't stop or doesn't repeat. So again, that's an example of an irrational number. Okay, and I just want to show you a picture of what's really happening here. We're missing one circle. This would be the natural numbers. Okay, so basically if you are a natural number, like the number 1 or 2 or 3, you're a rational number and a whole number and an integer, all of the above. Okay, whole numbers include all the natural numbers plus the number 0. Integers include all of those numbers, but in addition you can start including the negatives, and so on. And rational numbers include all of those integers, whole numbers, natural numbers, but also we get these, let me use purple, these fractions or decimals that stop, you can put negatives, or decimals that repeat. Okay, all of those are rational. Now on the other side, the irrational numbers, they are the ugly things, pi, square root of 2, and so on. So either a number is going to be rational or irrational if it's in this category of real numbers. Okay, but if it's a rational number, it could also be an integer, whole number, a natural number, or so on. So let's look at a question, what we might ask of you in relation to this. So we might ask, hey, here's some numbers. Are they integers or not? So let's just be reminded what an integer is. Okay, remember we use the letter Z or Z to describe integers, and they are all the counting numbers, but now we can include the negatives and the whole numbers, the positives. Okay, so those are integers. Now it's not quite clear, for example, if negative 27 over 9 is in fact an integer, but if you simplify it, you'll see that negative 27 divided by 9 is negative 3. Well, that is a counting number. That's negative. Okay, 1/2, on the other hand, will not simplify, so that is not an integer. 63 over 7 does simplify. It's just the number 9. So yes, it is an integer. Negative 99, it's just a nice round counting number. And so that is an integer. Negative 71.81, this is a decimal that we cannot simplify to be a nice round counting number, whether positive or negative. So we would say no in this case. Okay, another way we might ask the question is asking, hey, here's some numbers. Is each number rational or irrational? So let me pull up this picture again just to remind us of the difference between a rational and an irrational number. So remember, rational numbers, they can be written as fractions, they can look like decimals that stop or repeat, or they can just be nice round whole numbers or integers. Okay, irrational numbers, on the other hand, these are the ugly looking decimals. They don't stop and they don't repeat, and we often have things like pi or square roots that don't simplify. Okay, let's look at the first number, 16 divided by 7. Well, that's just a plain old fraction that has integers on the top and bottom. And if you are a fraction, then it's a rational number. Okay? Negative square root of 64. Now, at first I think, ooh, square roots. But then just remember, this simplifies just to be negative 8, which in fact is an integer, so we're on the rational side. Okay, 59.37, repeating this number on top means it's 0.373737. And so again, we're on the left-hand side. That's a rational number because decimals that repeat are rational. Okay, the next one, however, 9 pi. Anything that has pi in it is going to simplify to be a decimal that does not repeat and does not stop. So in this case, we call that irrational. Negative square root of 22. If you're not sure, put that in your calculator and see. And what you'll see is it doesn't simplify to be anything nice. So it's going to be a decimal that doesn't stop, doesn't repeat. So it's an irrational number. Okay, last example. They gave us a bunch of different numbers and asked us to say, okay, what are they? Natural, whole, integer, rational, irrational. Let's put them where they belong. So I'll go one by one. Square root of 5. If you're not sure, it doesn't simplify. You could test it in your calculator, but it's just a decimal that doesn't stop, doesn't repeat. Okay, next one, 0.3 repeating. Well, that is a repeating decimal, so it's rational. 0.33, that's a decimal that stops. So that's also rational. Again, negative 0.9, that's a decimal that stops. Negative 12. So integers have negative numbers that are nice counting numbers. So we can put it in the integer section. 11 over 4, any fraction with integers on top and the bottom will be a rational number. 6, well, 6 goes all the way in here. It's a counting number. Remember, the natural numbers just start at 1. It's also a whole number, an integer, and a rational number. It's in all those sets. And then pi over 6. Anything with pi is going to be irrational. Okay, so hopefully that helps you.